Welcome surfers, here is Joel and this is Rustlers. In today's atom we talk about numbers and conversions. If you haven't subscribed to this channel yet, maybe this can be the right time to do it. Thank you. In Rust, numeric conversions are always explicit and typed. The main way to do a conversion is the as keyword, and this keyword performs direct cast. It just changes the bits, even if that means losing part of the information. For example, converting a large integer to a smaller one wraps around, or converting a float to an integer simply drops the decimal part. So you can use the as keyword only when you clearly understand the result. But it's time to code some conversion and test it. We can start with a unsigned 16 number equal to 500. I can try to do a conversion to unsigned 8. To do this conversion I can simply write A as U8. Perfect. U8 can't contain U16, so theoretically this code wraps around and don't write 500 to the new variable b. Print the result just to see what the compiler do. A and B. Okay, let's give a try to this code. As you can see, the first number is 500, the second number is 244, so we lost something during this conversion. This is how the as keyword work. Another example with float. So let x is a float 32 equal to 3.9. Okay, and let y an integer 32 equal to x as integer 32. Also in this case I print both numbers, so x and y. And run again this code. Also in this case I lost part of the information because an integer can't represent the decimal part of a float, so the first number is 3.9 and the second number is simply 3. The as keyword truncates toward 0. For safer cases, Rust gives you another couple of traits, the form trait and the into trait. These two traits are for conversions that can't fail in any case, like, for example, turning an integer 64 into an integer 128. These traits are clean, composable, and are useful because it's the compiler that helps you to write them correctly. As usual, we demonstrate this directly with some code. So let a number n I64 equal to 42, the only number that really count. And now let m I128 equals to integer 128 from n. And we can do the opposite thing, so let k integer 128 equals to n into but into what? As you can see, into is implicit, so into picks the target of the conversion directly from the context. So in this case the compiler knows that the target is an integer 128. And now we can print both numbers, m and k. No. Yes, it's k. Okay. It's not a mistake. Let's run this code. Okay, and we have both numbers converted to an integer 128 without any loss and without any problem. But we can do something that is not considered from the compiler. For example, I can create a max number that is equal to the I128 max, a big number, and I can try to do something like this: max converted equal I64 from max. Okay. In this case, I try to convert a very big I128 to an I64 number. This is not possible because the first number is the double. I have the double size of the first number. So try to compile also this. In this case, the compiler helps us to do conversion in the right way because I can't convert an I128 to an I64. So when you use into or from, you have in any case you are sure that this conversion can't fail, is a good conversion in any case. Now I simply comment these two lines. Okay. And we can pass to the next argument. If a conversion might fail, you need other trait. In this case, you have two other traits: the try from or the try into. Both return a result, so you can handle errors safely instead of crashing when a value simply don't fit in another kind of container. We can test it with a big I64 equals to 300. Okay, first we can use the try from trait. So the try from trait returns a result. This means that I need a match to understand what is the result. Match U8 try from big. If the conversion is okay, I simply print conversion succeeded. Conversion. Okay. And I can also print the converted number. In case the conversion is not possible, I have an error and I can print it. So conversion error is equal to error in debug formatting, and it's okay. Perfect, let's try this code. Oh, match with a single A. Okay. Now the code compile. Yes, perfect. As you can see, it's not possible to convert an E64 to unsigned 8, and in this case you have a conversion error, but the code compile without any problem, because this kind of conversion with try from can fail. Let's try the other trait. So let small equal small is an integer 8. Okay. Match again, because I need to explode the result. Big try into. Okay. And also in this case, if I don't have an error, so in the OK case, I simply assign to my new variable the value small. If I have an error, in this case I print the error. So conversion error E, and I also return a generic value. Here I miss something. Yes, I miss this. Okay. This fallback value can be 0 in this case, because it's just a test. Closing this, and okay, the semicolon. Perfect. Also, in this case, the landing type of this conversion is implicit. So I write that small is an integer 8. The compiler understands that this try into must convert my integer 64 to an integer 8. Let's give a try also to this code. Okay, I in both cases have conversion error because I try to convert a bigger number into a smaller one, and this is not possible without losing something through the path. Finally, we must mention conversion between strings and numbers. These two are completely separate words. To go from a string to number, you can use the parse keyword. And the parse keyword can fail, because if I try to convert the B character to a number, this is simply not possible. To go in the opposite verse, so from number to string, you just call toString function. In this case, the function cannot fail, because any numbers can be converted in a character. We can test this creating a string from a number, always the magic number 42. 42 to string. In this case the result is simply 42, because any number, as I said, can be converted to a string. Let's print the result. The string S. Okay. I can do the opposite thing, so let parsed i8 equal match 42 as string dot parse. Okay. If the conversion is possible, I simply assign the parsed value to parsed variable. If I have an error, I do the same thing I have already done. Simply print conversion error. Okay. I miss here this. Okay. And return a fallback value 0. The semicolon. Okay. Let's compile and run this code. Expected something. Okay. Conversion error is equal. What I miss? Maybe this. Yes, perfect. Both conversion are completed without any errors. So in S variable I have a string 42, so something like this. and in the parsed variable I have a number 42 from a string. For this video it's all. See you in the next atom, and don't forget to follow, like, and to keep your thinking up on.